Here are the solutions to 2016 area and volume question. Let's read it. I hope you tried it first. Inside of a funnel of height 10 inches, it has circular cross sections as shown in the figure above. At height h, the radius of the funnel is given by that equation. So the radius is changing all the way down compared to a question we did like last time, which was on a cylinder where that radius stayed the same all the way through. So this one, the radius is changing as it gets closer to the bottom. And the height is between 0 and 10. There's a question. It's not a calculator question. And we're in inches. All right, find the average value of the radius of the funnel. So we know average value is integrating and then dividing. So we're going to integrate from 0 to 10 what the radius is, which is that. And then we divide by the difference of the bounds. So I'm going to write that as 1/10. I'm going to distribute. So I'm going to go 120, 1 over 20 times 3. And then I'm going to integrate. Actually, here's another way we could do it too. This would be better. So I want to show you something. So do you see how you have this 1/20th here? To make it easier, that 1/20th, we can multiply it in front and remove it from the integration as a constant of the integration in front and join it together. We multiply 1 over 20 and 1 over 10 together, and then it's going to make it a lot easier to integrate. So I'm going to do it that way. That's a property of integration. And then this is what I'm integrating. So first, 3 would just be 3h. h squared, you'd add 1 to the exponent and divide from 0 to 10. And we're not going to simplify it. So first, we're going to plug in 10. And then we would subtract and plug in 0, but I want you to know that 0 will give you the answer 0, so I don't even need to do that. And this is in inches. 1A done. So average value of whatever you're looking at, I see the setup. I could have done it too here. So let's say if I wanted to see it with this, you'd have 1/10 in front. This would be 3 over 20 h, and this would be h cubed over, when you divide, that would be 3 times 20 over 60. And then you would plug in from 0 to 10. You would get the same answer either way. All right, let's look at part B. It says find the volume of the funnel. All right, I'll be right. All right, to find the volume here, we're going to take the cross sections and do known cross sections to find the volume. So we're not going to use any formula because we don't have a formula for that funnel. If it was an actual cone, we would, but it's not. So for known cross sections, we're going to integrate, and the known cross section are circles, and the radius is given, and for a circle it's pi r squared, and the radius is this. So I want you to think of the cross section being pi r squared. This adds up all the circles as cross sections all the way up. And then for r, we put in what r equals, and this is what we're going to integrate. So we're going to square this. So we've got to do some algebra here. So we're going to have to distribute here. So that's 9 and h squared and h squared and h to the 4th. And then combine like terms and come back here. That's 9, that's 2h squared, that's h to the 4th. We still haven't integrated. Remember that constant, 1 over 20? So when you square it, so this square belongs to both. That's actually 20 times 20, which is 400. And then that 1 over 400, we can use that as a constant in front to make it easier. And then this is what we are integrating. So in front I have pi over 400. And then I'm going to integrate, that's 9h. I'm going to integrate, that is 2h cubed divided by 3. I'm going to integrate, that is h to the 5 divided by 5. And that's from 0 to 10. And then I'm going to plug in 10. Then subtract, when I plug in 0, the answer is 0, so I don't need to plug in 0. But that is the volume of that funnel. All right, last question. A funnel contains liquid that is draining from the bottom. At an instant when the height of the liquid is 3 inches, the radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. At this instant, what is the rate of change of the height of the liquid with respect to time? All right, so we're going to look at the radius. Which is 3 over 20, well, 1 over 20, 3 plus h squared. What we're going to do is take the derivative of that. So first I'm going to distribute, so I get 3 over 20 and then h squared over 20. And then I'm going to take the derivative of that with respect to time. So the derivative of 3 over 20 is 0. The derivative here is 2 times, so if I go 2 in front and then subtract 1 to the exponent, that's what that would look like. And it needs the hook, dh by dt. And then we're going to plug in some values. So the radius, so notice the radius is decreasing at a rate of 1/5. So decreasing means this number is negative. So the rate for the radius is negative 1/5. H says the height is 3 in the question, and the rate, this is what I'm looking for. What is the rate of change of the height? So I'm looking for dh by dt. Let me simplify this a little. I'm just going to divide. I know that the height in terms of a rate is in inches and per second. And so we don't have to, if you get and you really want to simplify it, that would be negative 4 over 6, which is negative 2/3. So the answer is negative 2/3 inches per second. That's the rate for the height, which means the height is decreasing at that rate as it is funneling through at the bottom. hey, Mr. G Math over and out. I'm super proud of you. Some things were a little bit easier, some were more complicated, but we got through it together. All right, till next time.